Let's get started on Module 8, Resource Management and Monitoring. In this module, we will discuss virtual CPU and memory concepts, resource controls and resource pools, monitoring resource usage using alarms, and vRealize Operations Manager. Let's start out with virtual CPU and memory concepts. VMware vSphere has 3 layers of memory. There is the RAM, which is in the ESXi host, and that is called host physical memory. The host physical memory is managed by the hypervisor, and it allocates memory to virtual machines. The guest operating system, such as Windows Server, is installed in the memory, which is allocated to the virtual machine, and applications run in memory, which is allocated to them by the guest operating system. 3 layers of memory. Now let's look at virtual machine memory overcommitment. In this example, we have an ESXi host which has 12 gig of RAM. One virtual machine is allocated 6 gig of RAM, and the second virtual machine is allocated 6 gig of RAM, and there is no problem. That's great. That's fine. But the problem is when we add a third virtual machine, which uses 6 gig of RAM. 3 6s are 18. We don't have enough RAM. When these virtual machines start using all of their RAM, it's not going to be there. So what happens is paging occurs. Paging is when a virtual machine runs out of memory and it writes to a swap file, a VSWP file, which is located on the hard disk. Paging is when the ESXi host runs out of RAM and the extra data temporarily spills over onto a swap file, a VSWP file, on the hard disk. Now let's discuss memory reclamation techniques which are built into ESXi. The ESXi hypervisor is a program, and it's designed to perform memory management, to efficiently utilize memory and to reduce the probability that paging will occur. So there are a couple different memory reclamation techniques, and one is economizing the use of physical memory pages. Transparent page sharing allows pages with identical contents to be stored only once. So here's the example on this one. The boss sends an email to all 100 employees, and the employees think that this email is so important that they save it as a separate file to the file server hard disk, which is on the data store. So now we have 100 files which are identical. With transparent page sharing, transparent page sharing allows pages with identical contents to be stored only once. A second memory reclamation technique is to deallocate memory from one virtual machine to another. And this is what they call the balloon mechanism. A balloon driver pushes certain virtual machines out of memory to make memory for other virtual machines. Memory compression is where the hypervisor seeks to reclaim memory by using compression, and this is like pkzip, but whereas pkzip is done on the hard disk, this memory compression is done in the RAM of the ESXi host. Host level SSD swapping is where we use a solid state drive, which is a very high speed drive, on the host as a host cache swap file to speed up performance. And then lastly, if we're totally out of memory, then paging occurs, and paging is when the virtual machine writes data, swaps out data to the hard disk. Now let's discuss virtual symmetric multiprocessing. But before we talk about virtual symmetric multiprocessing, let's just talk about symmetric multiprocessing and multiple processors and hyper-threading. As you know, a microprocessor is plugged into a socket on the motherboard. And some motherboards have two sockets on them, so you can put in two microprocessors, and this is called symmetric multiprocessing. It's when there are multiple sockets on the motherboard to support multiple CPUs, SMP. And then multi-core processors used to be they just had single-core processors, but now most computers have dual-core, if not quad-core processors. It just means you have two or more processors on one die, which of course gives more processing power. And then hyper-threading is the ability of a single processor core to run two programs or two threads at the same time, and thus it appears to a virtual machine as if there are two processors. Hyper-threading makes one processor appear as if it's two processors to a virtual machine. And of course you have to enable hyper-threading in the system BIOS as well as in the ESXi host configuration. Now let's discuss virtual symmetric multiprocessing, which combines all of these three things together. In virtual symmetric multiprocessing, if you have one processor with one core, then that's equal to two virtual CPUs because of hyperthreading. If you have two processors and each one is a quad core, then you have 16 virtual CPUs. And if we look in this example right here where we are creating a new virtual machine, this is an example of a quad-core processor with hyper-threading. CPU load balancing. If you have multiple virtual machines running on multiple CPUs, the function of the hypervisor is to distribute the load across the virtual CPUs. And this concludes our section on a virtual CPU and memory concepts.